Every decision you make, what to price, whether to cooperate, when to bluff, depends not just on what you choose, but on what everyone else chooses too. That interdependence is the subject of game theory. Most decisions are simple, your outcome depends mainly on you. But some decisions are fundamentally different. Your outcome depends on someone else's choice, and theirs depends on yours. Think about two airlines setting prices for the same route, or two countries deciding whether to build nuclear weapons. Each country's rational move depends on the other's. Neither can decide intelligently without thinking about what the other will do. This is the core problem game theory was invented to solve. How do we think clearly about decisions where the right move depends on everyone else's move? To make progress, we need to be precise. Every strategic situation has exactly 3 ingredients. First, players, the decision makers. Second, strategies, the options available to each player. Third, payoffs, what each player receives for each combination of choices. Players, strategies, payoffs. That's the complete vocabulary. With just these 3 things, we can describe any strategic situation precisely enough to reason about it. The tool we use to represent a 2-player game is called a payoff matrix. Let's build one from the ground up. Rows are player 1's strategies, A and B, columns are player 2's strategies, X and Y. Each cell holds 2 numbers, player 1's payoff first, player 2's second. Always in that order, row player first, column player second. Each cell contains 2 numbers, player 1's outcome and player 2's outcome for that combination of choices. If player 1 picks A and player 2 picks X, 3 and 3. If player 1 picks A and player 2 picks Y, 0 and 5. If player 1 picks B and player 2 picks X, 5 and 0. And if both pick their second strategy, 1 and 1. 8 numbers. 4 cells. A complete description of the game. Let's make this concrete. 2 coffee shops, roast and grind, each decide every morning, hold price, or offer a discount. If neither discounts, customers split normally. Both shops do well, 10 units each. If shop A holds but shop B discounts, customers flood to the cheaper option. Shop B earns 14. Shop A earns only 2. Symmetrically, if shop A discounts alone, shop A earns 14, shop B earns 2. And if both discount? Customers still split evenly, but both shops earn less per cup. Both earn 4. Now look at what each shop sees. Shop A checks its rows. If shop B holds, discounting earns 14 instead of 10. If shop B discounts, discounting earns 4 instead of 2. Either way, discount. Shop B sees the exact same logic. So both discount. Both earn 4, when they could have both earned 10. Individual rationality. Collective loss. This tension is the heart of game theory. The coffee shop isn't a special case. This structure appears everywhere. 2 pharmaceutical companies, each prefers the other fund expensive research. Both cut back. Innovation stalls. 2 countries on tariffs, each raises barriers to protect domestic industry. Trade collapses. Both lose. 2 social media platforms on moderation, each under moderates to stay engaging. Users on both platforms get worse content. Same structure. Different domain. Same trap. Before we go further, we need to be precise about one word, rational. In game theory, rational means exactly one thing. A player always chooses the strategy that maximizes their own expected payoff, given their beliefs about what others will do. Consistent preferences. Forward-looking. No random errors. Notice what this does not mean. Rational does not mean selfish. Your payoff function can include genuine concern for others. A parent who sacrifices for a child is rational in this sense, maximizing a payoff that includes the child's well-being. Rational also does not mean omniscient. Players can be wrong about what others will do, they act on beliefs. This assumption is a simplification, but it's a remarkably powerful one. So here's where we are. We know what a game is. We can read a payoff matrix. We know what we're assuming about players. And we can see the tension. Individual rationality and collective outcomes can point in opposite directions. The question we haven't answered, the question game theory is fundamentally about, is this: when rational players face each other in a game, what will they actually do? Not what should they do. Not what would be best for everyone. What will they do? The answer requires one more concept, pinned down precisely by a 22-year-old named John Nash in 1950. The concept is called Nash equilibrium. And that's episode 2. Thanks for watching. If you want to understand how rational players resolve these tensions, episode 2 builds Nash equilibrium from scratch. See you there.